Okay. We've started, and the camera is there, so you're in camera.
Okay.
Yep.
Will this work if we, after console we
yeah, looks perfectly fine.
Yes, if it is after console, it's no problem.
That will change. I could show that kind of. Well, yeah, we could take it in a break, maybe. Okay, welcome back. So we will start looking at creating or mimicking classes that you're used to from other languages. I mean, the reason why we... Whoa, sorry. Yeah, good thing it's not streaming. Let's do it like... Or was it the correct one? That one. Okay. Mixed. Like that. No. That does not work at all. Oh, it does. It's just laggy. Strange. How can... But... It started showing things I didn't break. Strange. Now I think it's... Yeah. No. Okay, if I do that. It looks like that. Give me a minute. That is really strange behavior. I will just restart this. Well, now I actually think it works. So, where were I? Back to that one. You'll have to do without me on camera. Yeah, so you are supposed to create student objects. We need one object for each and every student in a course, for instance. You could do something like this. Students, let students create an empty array, and then we do a students.push. We add an empty object with a name, and an ID. Something like that. Okay, that is oh, perfect. We have an array with a student. Then we need to add another student. So of course we could do something like this. we get 2 students. This is quite a trivial example because we only have 2 properties and no methods and things like that. However, if we were supposed to, I mean, create a lot of students, this approach is quite error prone because, I mean, if we do something like we forget ourselves, so we do something like that. Now we have objects in this array with different properties for their student ID. So this will be quite hard to handle in the next step when we might depend on that student ID. So doing it like this is not a good way if we are supposed to create a lot of objects which are supposed to be the same, have the same blueprint. This is where you have used classes, of course, in Java. You create a blueprint for students and then you just instantiate objects. There are several different ways to mimic that in JavaScript, and we will start from a simple solution and work ourselves all the way up to talking about prototypes, for instance. One way of doing this is use something called the factory pattern. Have you heard of the factory pattern? The factory pattern can be used in other circumstances as well. It's just that, okay, so instead of creating each and every object separately, we could add a factory or create a factory that creates objects for us. So let's do that. I will copy this code. It's faster than I write everything. Okay, we create a function called createStudent that takes 2 parameters, name and age. And it returns an object. This is an object that is returned. We return an object with a name mapped to that name. We can do this if we like. It's quite common to have private members of a function with an underscore in the beginning. Then you can see the mapping more clear. We add a greet method because we need a greet method in this example. And then I could create an array of students, and then I push in the result of createStudent ln30, which is an object, and createStudent Peter. So this will more or less create the same thing. Then for each student, I call student.greet, and then you see that Ellen is greeting you and Peter is greeting you. We could actually make this even neater by removing this one again. This is also a syntax sugar that if you have a property in an object, you can map that property name to a parameter in the function without the need of doing that. So in this case, we could actually do it like this. It's the same thing. We create a new object with those matched, the parameters to the function mapped with the object properties. We run it and it works. Okay, let's start to talk about a little bit about optimization. Do you see a problem with this approach? A lot of function copies. That's correct. This greet method, it's simple in this case, but I mean this could be more complex. For each and every object created, it gets its own greet function. So on the heap, there will be, if we create 1,000 students, there will be 1,000 greet methods on the heap. If the JavaScript compiler doesn't do a lot of magic in the background and optimizes things for you, probably can do that, but it's not, we can't be sure of that. Okay, question. How could we still have a greet method in each and every object created, but without duplicating it in the memory? Yeah, create it outside of the function and treat it as a reference. So I move this one, or So we have a greet variable, and then we could just do a greet, because this one will try to map against that one. Run it. Still works. However, when this file is loaded, this one is added to the memory, and for each and every object that we instantiate, it's not the right word, for each and every object we create, the greet will reference this function in the memory. So now we have optimized it a bit. I tend to use the factory pattern sometimes because it's often you just want to create a simple configuration object that you are supposed to use in certain circumstances, and creating a factory is quite an easy way to create those objects without you risking to duplicate stuff in the wrong way. But there are other ways of doing this as well. But you should know that this is called a factory pattern, and what it is and how you could utilize it. Questions on the factory pattern? It's quite simple, actually. Okay, let's move on. This is probably a word you know, right? The constructor pattern. So in languages with classes, you have a constructor. We have that in JavaScript as well from the beginning, but doesn't work like classes do. So let's copy this example. It's the same one with the students. That. First of all, we create a function called student. You could do it like this, or of course I could make it the opposite way around by doing let student const student equals function if I like. But in this case I did it this way. Anything you can notice about the function declaration? Yeah, there is a capital S. And that is the same thing in Java. If you create a class in Java, you always capitalize the class name. This is a convention in JavaScript that if you're creating a constructor, you are using a capitalized first letter. It's just a convention, but everybody tend to follow it. Please do. Do not have this with a small s like that. Capitalize it. Okay, so this tells us that this is not the usual function. This is a constructor function. A function that is used to create instances of objects. It's still just a regular function, but a constructor function is supposed to be called with new instead of a regular function be called as a regular function. So in this case, we are supposed to call this function using the keyword new, like that, and then send in whatever we like, just as I did on this row. So if you call a function using the new keyword, you're telling that function that it, instead of returning undefined, if you don't return anything, this function will return a reference to a new instance of itself, more or less. So when we call it like this is return this will be done even if we don't write it. So often when you're creating a constructor function, you just make sure you don't return anything, because then return this is returned, or this is returned. So what I do in this case is, since this is returned and this being the new instance, I could operate upon this inside of the function. So by doing line 2, this dot name equals name, I'm assigning a property to the instance and I'm connecting it to that parameter. The same thing with age, and the same thing with greet in this case. This is being called a method, and those are properties. Yep.
No, this name equal name, but this the second name, what is it variable?
Yeah. So
it should be like a global field.
no, this one is this one, and that age is that age.
Yeah.
Yeah. So they match, and this name is the property that will be attached to the object returned. So you can almost look at this constructor pattern as a factory that creates new objects. You reference that object that will be returned by the this operator. So this dot name will create a new instance on that object.
No, I mean like in Java, we say this name equal name. We should have fields to or here is different.
Yeah. Okay. So yeah, we will get to like getters and setters and fields and stuff later, but not yet. We're not that yet there yet. So just remember, capitalized function name, you're supposed to call it by new. I could of course call this without new. However, then not undefined is returned, and it will not work.
This name, but this name, which name? There is no variable called name to assign it to the parameter.
Well, that is the thing with JavaScript. You don't need to have it from the beginning. You could always just create it on the go. So what I do in this line is I'm basically, this is an empty object from the start. So this is referring to an empty object. And what I do on this line is that I say that, okay, take this empty object and attach a property name to that empty object, that being that parameter. So you can dynamically create those properties as you go. But of course, I could do this in other ways. I mean, I could do it like that if I like, and add the parameter in that way. But as you don't need to have the class declaration where you have told the compiler which properties are available. You could create those properties as you go. Okay. We're back to that problem, right? So for every instance of this object, we're yet again creating a new function. When using constructor functions, there is another way of putting, or another way you can put methods on the object, and that is called the prototype. I think we will have a picture on that one, hope. Yeah. So this being called the constructor prototype pattern. And I will explain this with an image soon. We will just have a look of what we do first. So I remove this greet property or method from within the constructor function and places it outside. Then I do a student.prototype greet equals function. What this is, you saw me do this with arrays before. So this constructor function has something called a prototype. On that prototype, which is an object that will be common for all instances of this constructor, we could place this greet method. Then all objects created from this prototype will, or from this constructor, will share the same greet method. Just making sure it will work, and it does. And I'm logging something else, yeah. So let's have a look at what this is then. So when I create instances of objects, they all have a constructor function. And we can reach that constructor function by, if I go back to this, no. Hjälp. Jag hade ju den där. I didn't say this before. Let's get that one back. What I do here is that I say that, okay, take the first student and dot constructor. So dot constructor on an object created with a constructor pattern will get you a reference back to the function creating the object. So that's just a reference back to the constructor. So if you're uncertain which function is the constructor, you can always use that, but you probably never will. However, so looking at this picture, we have a constructor property that points to the constructor function. But we also have something called a prototype. And so these are the instances that we created from this constructor function, but they will get a hidden reference back to its prototype. The prototype being another object which is common for all, which is in common for all of those instances created. And what I did when I removed the greet method from each instance and moved it to the student.prototype, I placed it up here. And if we try to do student0.greet, it will look in this property list and try to find the greet method. If it doesn't find the greet method, it will follow the prototype reference back to its prototype, and in this case it will find greet there and it will run it. But it will run it with this referring to that instance. So if I'm using this inside of greet, it will return to that object. And for this object it's the same, this will refer to that object. This is kind of similar how the scope works for variables in the function, that it goes to its outer scope. In this case, it goes to its prototype. And this is starting to look kind of like inheritance, right? I mean, you have something up here that those inherit, so they could share functions, for instance, functionality. And actually, you can do something called prototype inheritance, or in JavaScript, we have something called prototype inheritance. And that is basically you creating an object and assigning the prototype reference to that object, and then you made an inheritance. And you could, I mean, you could do that in a chain if you like. This is actually quite different from how Java is created in the background. It's nothing like this. In Java you have the classes and things. In JavaScript you have the prototypes. But you can use this to kind of mimic the way Java works if you like. This prototype reference, you never ever more or less use it. It's hidden in the browser. You can access it, but you probably never should, because that is automatic. However, you can reference the prototype property on constructor functions. And that is what I did here. I referenced the constructor function dot prototype, and then I reached that prototype, and then I connected a greet method on that prototype. You could do you could add a primitive data type to the prototype as well. However, so if we look at that image. Now I have a number of students int on this one, the prototype. If I try to read that one, it will follow the prototype chain and it will read 32 or whatever I wrote. However, if you try to modify that integer or number that you stored on the prototype, it will actually make a copy of that int and place it on the instance and increase that one. So this one will stay the same. Just a good thing to know that primitive data types are handled that way instead. Or well, I get reference types are handled the same way as well, because you will probably copy the reference to the instance if you try to alter greet, for instance, in this case. Good news. What I'm telling you now, you should like have some kind of understanding about. However, we will get you to a point. You will not need to do this if you don't like. We will get to something, a newer syntax, but I'm just showing what leads up to that syntax. We can do something called prototype chaining or prototypal inheritance. Let's open Slack, I forgot. Ooh, yeah. So I've created a person. It has a name, NN, an age, 17, and a greet function. So this is yet again a simple object. And then I use that object, person, to create new instances using a function called object.create. This is another way of creating objects. I'm basically saying, okay, I have object, I want to create a new object, and as the first argument, I will tell which prototype to use for that object. So I create a new object with person as the prototype. So basically, you can say that student inherited person in this case. Because, student.greet NN says hi. But student, if we, I think at least, if we do a if I log the student object, it's empty. It's completely empty. It's just an empty object. But still, if it still has properties like greet and age, and that is because those properties are on student's prototype object. So as you probably have seen, if I do this, create an empty object, new object dot, oh well, that's not representative. We can do this, console.log, hope this works. I console log the new object. Yeah, it's empty. But I mean, this didn't crash. New object seems to have a function called toString. But it's empty. How could it have a toString? Yeah, it's the same thing. An empty object has a prototype that has a toString method. In this case, the toString method kind of just says that it's an object. But so even if the object seems empty, it has its prototype, and you can call objects on arguments on the prototype, or properties on the prototype. Okay. Prototype inheritance, and of course you can do this in a chain. I could let pupil, is it called that? Is that elev? Yeah. Equals object dot create student. So that is some kind of other student, and then we could, yeah. So in this case, pupil is a student that is a person. So you're kind of making a chain of prototypes. And then you could have different methods on the different objects. And you could, of course, overwrite greet in a pupil. So the pupil will say greet in one way, the student in another, and person in a third way. So this is kind of like inheritance that you're used to. But it's called prototype inheritance. Yeah. Yeah. So the question is, you can only have one prototype. Yes, you cannot do multiple inheritance. However, remember, in JavaScript, you can compose new objects. So you could basically take one object, take what you need from that object, take another object and what you need from that object, create a new object and use that as a prototype. And then you will kind of get multiple inheritance, even though you have decided with what to borrow from which function. Okay, someone's always asking, and I think you might have asked this already. I don't remember, but if we let's I want to go back. Yeah. Okay, so going back to this example. In Java, you have private properties, you have public properties, you have protected properties, and so on. We don't have that in JavaScript. We only have, I mean, you have never seen the keyword public or private or protected. We're just creating variables, and if we are using this, they become public, and if we are not using this, they are private. So the student has a private variable, it's assigned to 10, and this variable is, you're not able to access this from outside. Yeah.
So if this was like a private variable in Java, then I would be able to access it from greet, but we can't, right?
Yeah. That is my point. So the problem now with this private variable is that the public method greet is not able to access the private property private variable, if we should compare this to Java. But it's quite obvious in this case, because I mean that variable is inside of that function, and greet has no access to that function. It has access to this object. So Douglas Crockford made an attempt of creating its own kind of terminology, thank you, surrounding this, calling this a public method. If you do it like this, assign it inside and duplicating it, he called it a privileged method. A privileged method would be able to have access to the private properties because it's inside of the function. But with the drawback that it's duplicated in memory. Don't think about it too much. I think in JavaScript in general, you're not so concerned about leaking private data from a function that as you are in for instance, Java. At least that is my experience with this, that often you don't care that much. You kind of use the notation of an underscore when something is supposed to be private, and other developers respect that, okay, I probably shouldn't do something with this variable. Could even be easier to test in some cases when things are public. But yeah, we will get to another way of looking at this. So I think this is what I'm explaining here. Yeah. One way of, we will get into this with getters and setters, and what's it called in Java? It's called, you said it, I think. Not all at once. One. Oh, you say getters and setters, but you have fields and stuff. Yeah. I'm not used to the Java terminology, so but have a look at this. So this is, I mean, if you're just supposed to use the constructor pattern and create getters and setters, you would probably do it something like this. You create a function student, it has a name. You have a this.setName, so you create a public method called setName, which is a function that takes a parameter name and assigns it to that that private. This is kind of weird, actually. It's not. It's really not weird, but it's. You need to understand one thing that we talked about before. That is, in the scope of the function will look at that name if it doesn't find a name inside of that function. So in this case, if we send in a name, it will be assigned. This name will be assigned that name that we send in to set the setter. And the same thing, the getter will return that name from this private variable name will be returned with getName. And then we call setName, because if you create object student and send in a name, we want the setter to be run. In this case, it doesn't matter because it doesn't do anything. But normally in a setter, you will have some kind of validation of the name. And we will make sure that the name called with the constructor is also run through set. This works. Now you can, from this greet method, you can access the name by getName. You can create new students, and the students can greet. So this works perfectly fine. However, it's not that beautiful. I mean, you have this .setName. You need to duplicate the property name using a set, but it works, and it's perfectly fine to do it this way. However, we have something called define property. And this is probably a little bit more like you're used to. So define property on an object like this. So you call object.define property. As the first parameter argument, you say which object am I supposed to create the property on. In this case, it's this, because we're inside of the constructor function. Then you set the property name to name, in this case. And then you send in an object with configuration of this property. And in this case, there is a get method. So we are setting a get and a set. Those are predefined. And we tell what to do when we get something. Well, return the name. What to do when we set something. Well, in this case, I'm just adding some brackets. Yep.
Yeah, you said earlier about that we could steal the function and call that on some other
Yeah.
this thing. But then the private variable should still be the original.
If we steal a function from another object, then the private variables will still be.
Those from the
Yeah.
functions declared.
Yeah, they will, because you will get a Oh, well, if you do it with... If you do it with this one, where you have in this case, you would borrow greet. So you will add greet to another function, another object, sorry. And then when that object calls its greet, this will refer to that object. So in that case, that object needs the get name setter, because that is a getter, because that is on this, and this is referring to the new object you have. So then you need to duplicate those as well, because this one is dependent on the object having a get name. Okay, so what this does, this is just a fancy way of creating a getter setter. The good thing is that when we use this one, we don't need to call a function. We could just student 0 dot name equals like that. So I changed from Peter to Johan. It crashes. Unterminated temporal literal for each. Oh, sorry. Yeah. Okay. So instead of calling set name, we could just call the property, but as you can see, name will run its setter and do that validation. That is kind of like Java, right? Or C# at least. I know you do it like kind of this in C#. The syntax is probably different. However, if you want to read up on something, you can read up on define property, because you can use define property to fine-tune properties. You can freeze them, for instance, that will have a value it can never change. You can read only. Well, in this case, if we remove the setter, it's read only. So you can only get, you cannot set the value. You can do a lot of things with define property to fine-tune how a property on an object should behave, if you like. Okay. Let's move forward. Yoo-hoo! Now you should be happy, because you will probably recognize this. So, putting it all together, the standard committee consisting of, amongst others, earlier named Douglas Crockford, they discussed for a very long time if classes should be something that was implemented in JavaScript. And this is something that is truly dividing the community. You will find JavaScript developers that will not touch classes at all. That just opposes, says that classes is for other languages, it has nothing to do with JavaScript. And you will find others that will like embrace them and use them because they are used to using classes. I will not take stand in which side I'm on. I'm kind of in the middle. However, knowing what you're supposed to do in the rest of the course and how the browsers are working with something called custom elements in the browser to create own custom HTML elements, I know that the class syntax is quite powerful in that context. So I would actually recommend, especially for you with a Java background, that you kind of use the class syntax. The class syntax is actually only an easier way of writing everything that we've learned so far. Define properties and prototype properties and all of this is just a prettier syntax for doing all of those stuff. I think I've written some comments here. So first of all, we use the keyword class. Good thing that was reserved in the language. So we have class and we call it student. So far so good. Then inside of the curly brackets, if we just want to show this. Okay, if you look at this code, I will not copy it into the IDE, but if you look at this one, you have the function, the student constructor here. It starts here, it ends here. Then outside of that constructor function, we define the student, the greet method. I have a lot of students that find this quite strange, so they move this declaration inside of the constructor function, and it will work. However, the thing with that is that for each and every object created, this greet method will be reassigned. So it will not create duplicates, but it will kind of create that method over and over and over again. But they tend to do that because they are so used to having a class starting here and ending at the bottom, and everything in between is the class. But that's not the way to do it when you work with constructor functions. But however, the class syntax does this. So it has a curly bracket up here, and it ends here. And everything in between is things concerning this type or class. I shouldn't say class. It's not truly a class. It's still called a type, kind of, but you could look at it as a class. So, okay, inside of this student class, we have a constructor. So that is the constructor being called when we run new. So if we do new student, this constructor is being called. It's kind of like PHP, I think. They have this notation as well. Then I do a this.name. This will call the setter. And getters and setters are defined like that. You just write get name or set name. What happens in the background is that defined property is being used, like we saw on the last slide. But this is a much easier way of writing it. So we have a getter, we have a setter, and we have a greet method. And if you just add a method name like that, that will be a prototype function. So you don't need to write student.prototype. It's done in the background. However, when you run this, it's exactly the same as we have done in the last example. It's just a better syntax, I think at least. However, if you're really into working with the prototype, you will probably hate this syntax. You're allowed to do whatever you like.
But I don't understand, you know, how like return this to name, underscore name, but there is nothing in the old class here is underscore name.
No, that is wrong. No, it's not. Let's see. Why do I have an underscore on that one? It's this. Let's see if that works.
Wouldn't you otherwise override the name?
Yeah, I would probably, but yep. I get a circular reference in this case, because when I do this .name, this setter is called once again and once again and once again. So we will get a circular expression. And in this case, so underscore name in this case is just a way of storing the name value underneath the hood.
Yeah, but this underscore name, is it variable or what is that? It's really strange.
Yeah, so that will be.
There is no variable here to store value in it.
We are just creating it, just as the last time. We're creating it on this object to be able to store. Because if we have this get name and this set name, and this is the public interface, so we want this property to be called name outside of the function. However, if we were to use the same name here, we will get a name collision on those. So instead, I'm saving this inside of my object with another name.
But for me, it's not logical. This syntax.
No. Yeah, if the syntax isn't logical, you could always fall back to I mean, it's the same thing as no, wrong way. It's the same thing as this one. However, it's like if, I guess that one would be named name underscore name instead. Yeah.
It's completely different than C++.
Yeah, it's completely different than C. And this is the thing. I mean, C++, C, Java, they are all kind of the same language, C#. They come from the same language tree. JavaScript has borrowed a lot of the aesthetics, how it looks and how it feels from that tree. However, it stems from a totally different tree with scheme and Lisp and things. So under the hood, it's completely different. And that's why the logic will be kind of backwards in some cases. But this is still, that is just to memorize this model, more or less. So you look at this model when you want to do something, if you want to use a class, like a class. Because instead of doing the prototype inheritance, you can now do things like this. Class polygon has a constructor with a height and a width. And then we create a class square that extends polygon, which has a side length, which calls super, and super being that class constructor. So this is probably quite familiar if you're used to classes in Java. Under the hood, a lot of object.create with prototypes are involved. But this is just another interface for the developer. And that is the thing with JavaScript that you must know, that JavaScript is this kind of Lego for programmers. I mean, you can do things in so many different ways. There is not just one way to create an object. I've probably shown like 10 different ways of creating objects in JavaScript. I mean, you could get away with always using classes, if you like, and always creating objects from classes. That's totally fine. However, it will really be overkilling some tasks that you do with JavaScript sometimes. Sometimes you just want a simple object and send that simple object to a function. And then creating a class and blah, da, 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 when you just can do brackets, name, colon, something. It's kind of overkilling it, but you could if you like. Yeah, I've kind of talked about this already. What does this do? Oh my god, I haven't read up upon this. Object design, oh my god. Let's see what it does. Probably need to help each other on this one. So looks like we have a student. That is a factory. Yeah, oh, this is, oh, I think I talked about this in the recording, right? You could have default parameters in JavaScript. You couldn't before, but you can now. So this is, I mean, this is an arrow function. So this is a function declaration with a name and an age, and name being n and an age being default to 18 if we don't add anything else. So this is a factory that is returning a new object which are using a sign to, I almost don't know what the sign does, but it's using a sign supervisor. I need to, forget about that one. I'm not sure why I had it there. I don't know it myself. But it's probably a way of doing composition in a fancy way. So we have a student Niels, a student Ellen, Elsa.se supervises that one. So we are so supervise. So this is kind of telling that this student will supervise that student. So we're sending that student to supervise. I can't do it now. Let's talk about modules instead, because that I know. When we are writing an application in Node, if I'm logging this, okay. I'm just logging this inside of a file that is run with Node. And we see this is an empty object. So when I'm writing programs in Node like this, my file is a scope, or it's its own object. However, if we start to transition to the browser, I mean, you could, oops. Oh, you can't, okay. Clear. Let's make it bigger. If I try the same thing in the browser, you will see that this refers to something called a window. And if we look at window, you will see an object with a lot of methods and properties. And this is basically the whole web browser window or instance or tab in this case. So you can I could access everything on the page, I can access the URL, I can change a lot of things with this. So when we are writing code for the browser, we are in this environment where we have a lot of public things that we could mess up if we are not careful. And this is the environment we will be coding in starting next week. And if I am to do something simple in this environment, if I do let hello equals 10, I mean, this is just, think of this as being in a file. I'm just assigning the hello variable. Then sol.log window.hello. Didn't work, damn it. They might have changed something as well. Yeah, it is. And that was the point. I can't see it. This might be up for change because sorry, I should have used it's strange that it didn't do it actually. I'm just trying this then. Okay. This is good programming. Oh, well, didn't prove my point, but my point was this, that when we will see this next week, but when we are creating variables just in a program, JavaScript program, just linked in to our web page, if we are not careful, we could actually end up adding a lot of variables to the global window object. And the global window object, all running applications in this context can access them, and we could like mix things up with each other. And it's really important in that environment to be able to structure your code so that your code is run in your own environment and other code is run in another environment. And to help us with this, we have something called modules. So we could arrange our code into modules, and the module being this self-contained application environment. There are a lot of ways of doing this, I think, and I'm getting back to your question. One way that you could see is something like this. The syntax is kind of clunky, but no. Like that. What I've done here is that I have a self-invoking function. This is called a self-invoking function, a function that calls itself. So I create the function and the function body, and then I use the parentheses to just call the function directly. The reason why I have those yellow parentheses is that the compiler, I think, will complain if I don't, because it's just a quirk. You can't start with a function otherwise if you don't have the parentheses. Look at the output. So inside this function, that is a scope, and I create a variable hello in that scope, and then I log hello. So obviously we will log 10. However, if I log this, we haven't changed the outer scope. There is nothing on that outer scope. If I were to do this dot hello equals 10, this dot hello, it will still be the same. And remember, if this outer object was the window object in the browser, this is good practice to do, because then I will run my code in my own scope without polluting window. Who is considered to be calling that function? The outer scope should... That is a good question, because if the outer scope was considered to be calling that, and I'm using this, as I did here, that you shouldn't do that actually. But it's strange that... Okay. This is a relic from the past. Huh? I can't inside of... I think that question opened up a rabbit hole for me. I need to... I might be that something else is going on when you have a self-invoking function. Because otherwise I would be able to reach that. And I couldn't. Maybe the parentheses are doing something with setting the scope to an empty object or something. I don't know.
If we delete, we can try to delete the parentheses inside.
Not sure what you mean.
If we did this parenthesis inside the function, the self-calling.
Yeah, inside here.
Yeah, this. Yes, this.
That one?
Yeah, if we delete them.
Okay, but yeah, if we do it like that, then this is just an anonymous function doing nothing at all, and it will never be run. It will even say that it's not correct because I don't have a name. It needs a name, and now I'm only logging that, and this one is never called. So that's why we had those parentheses to call it immediately. But yeah, that was a side note. Let's go into modules. So when we start working in the browser and even in Node, we will need modules, basically. And there are, I will not get too theoretical about this, but there are two kind of, or even three, but two major ways of working with modules, the common JS and I forgot the other name, AMS or something like that. Node, which is the application platform running on a server, has utilized one way of doing this, and often referred to as Node.js modules. This is what you're working with when you're using npm for install, when you can like import other modules from other projects using the npm library, and you have yarn if you want to work with that instead. Those modules work in Node and are heavily used in Node. However, in the browser, we haven't had any modules at all. So in the browser, we had to rely on using Node modules and having a pre-compiler changing this module code into self-invoking functions that I just showed. So, and in this course, we will use something called Webpack to do that. So that basically means that you can write code as you were in Node.js with Node.js modules, and then Webpack will transform this into stuff for the browser that will not intervene with a window object. However, in ECMAScript 2015, we have something called ES 2015 modules, and that is V3C's approach to modularize the browser. We are really in between right now. Those modules kind of work in many browsers, but not to a full extent yet. But almost. It's kind of, there are some quirks in Firefox, I think, that doesn't support it all the way, but they probably will soon. But you will be able to use modules natively in the browser, say the coming year or two. But we're not there yet. So we are really in between right now. I will just show you how modules work in Node. It's quite simple. Let's do this the right way, maybe. Now I will create a new file. Greetings.js, and we have app.js. In greeting.js, I will do this module.exports. What this says is that, okay, this greetings.js will export a function called say hello in English, which is just a simple function returning hello. And it will also export say hello in Spanish and in Swedish. Really simple. Of course, this will be more complex as we go on. To reference this file, greetings.js, inside of app.js, we're doing something called require. And then we just add the path to the file. However, we cannot do this, because if we just write a name like this, the Node interpreter will try to find this library greetings inside of Node modules. I don't have Node modules now, but it will assume that this is a public public library called greetings.js. So we need to start with a dot slash. Whoa, sorry. Dot slash like that. But you can omit the JS. That is, you don't need to write .js. You can if you like, but you don't need to do that. And then we could just assign that to a variable. And what greeting is right now, it's an object with all of the exported methods from within greetings.js. Console.log greetings. Whoops. Ah, no, go away. So you can see that greetings is an object with say hello in English, say hello in Spanish, and say hello in Swedish. And that is pretty much it. It's no harder than that. But then now we have two modules. We have one greetings module and one app.js module. Of course, if you were to use a library, you find a library on the web doing something you need to sort an array or whatever, you can just do an npm install, and then you reference it with require and the name of the module, and then you can start using it. So it's pretty similar to how you work with packages in Java, for instance. And I really think, actually, if we have a look at could just show how the new syntax looks. This is the new syntax for the ES 2015 modules. You import something from a module. That is pretty close to Java, or think. And you export by I should have looked at export then, I guess. Oh, well. You can do that in many ways, yeah. And you just export like that. Export function get. So you use the keyword export and import instead. Under the hood, there is probably a lot of differences because npm is struggling really hard with starting to support native ES 2050 modules. I think you, at least in Node, you can use import and export, but you need to add a flag, experimental flag to the latest version of Node. And I know that npm is struggling with importing this kind of library handling into npm. They are doing that by creating a new file extension called mjs, I think. But this is, I mean, we are really in a shift right now. So next year I would know more about this, because then we will get probably past the threshold. What I would like you to know is there is two ways, basically, of working with modules in Node and in the browser. Or, well, there is only one way in the browser. But in this course, we will, and all examples, I am using this syntax with require and exports. But you're free to use another syntax if you like. However, this one will work together with Webpack, and I will show you how next week. Yep.
Here, it's give us say hello in English, say hello in French. But how can I see the value of these? Like
yep.
Hello.
Yep. So in this I have the greetings. I do dot say hello in Spanish. I call that function, and it says hola.
Okay.
Yeah. But you could always, I'm not sure, no, not in this, but if you debug, you can always follow. I mean, if you debug, you can always go into the function declaration and look inside of it if you like.
Okay. So it's like variable contain three functions together.
Yep. It's an object containing three functions.
Oh, okay.
Yeah, so it's an object. But I mean, if we go into greetings, you can also do something like module.exports name equals whoops. And then you see, okay, so I also exported a property called Johan. And what you can see is that this is actually just an object. So you can export any object you like from within a module and just catch that object on the other side. You can export a class. So if you're creating a class called student, you just do module.exports student. Simple as that. Then you just require that student and you can start working with that class. It's really quite simple. Okay, so that's a lot of topic to cover on one day. Your heads will explode soon, I guess. What I would like you to know is programming in JavaScript is quite simple in many ways because it's quite a simple language. I think Crockford calls it a simple, silly language. And it really is. But it's quite powerful because you can use it in so many different ways, and you can use it in ways that you don't know, like with the self-invoking functions. I've never tried that, and let's see what happens. Compared to Java, I know half of you will hate this, and half of you will love the language. And those of you who will hate it will probably say that you hate it because you have no clear rules. I mean, when you code in Java, you have a path. You know, okay, I create a class, I do this, this, this. It's quite staked out. However, in JavaScript, you're just with a blank paper and, okay, so now what? Oh, well, you can do it like that or that or that or that. You can do it in any way you like. And that is quite hard in the beginning because you have all of those tools and you don't know what to choose in a certain circumstance. But I think we have made a change from last year. And the change is when we come to the browser, we are quite heavily using something called custom elements in the browser. And those custom elements are kind of like giving you a path of how to create those objects in the browser. And I think that is a good thing because otherwise you would have the language that is totally free and then you have the web browser in which you can do it in 100 different ways. But those custom elements will probably get you into some kind of mold that will, or path that will get you in the right direction, I think. At least that was the students in Kalmar said when they had this version of the course, that it was clearer than before. I hope so. I've been speaking of Crockford. I would just like to mention that now we had lecture 4. If you look in those, you have external resources. Could go to that one. On the bottom of the page we have external resources. In this case it's Crockford on JavaScript, and Crockford being this kind of father of even if Brendan Eich was the one creating JavaScript, Douglas Crockford is kind of like the one outspoken about JavaScript and has been forming the community for many years. He recorded a series of lectures 10 years ago, and I still recommend at least the first couple of ones, because in those he talks about how did we get where we are today, how did this language become the language it is, and it's quite good to know if you're coding JavaScript. However, when you get to the later ones, I mean, those are recorded 10 years ago, and ECMAScript 2015 was only on a paper back then, and a lot of things has happened. But he talks a lot about how the changes in ECMAScript 2015 came to be. So it could be good to watch them as well. I've also added fun functions. I've added some references to MPJ as well. I recommend watching those as well. And I recommend reading up in the book. Remember, the second assignment, we have an oral hearing. And the oral hearing will question you about the theory in the course. So you will not get passed by only doing the assignment and think that is fine, because you will need to be able to explain the assignment and the constructions you've done in the assignment, and you also need to be able to answer questions about the language JavaScript. But I can promise you that I will not get into like, okay, could you please do a prototypal inheritance? It's not that kind of questions. It's more like, what's the difference between var and let? What is a scope? More of those like basic questions, but you need to read the theory as well to be able to pass those hearings. Good. That was that for this lecture. Do we have any questions regarding something that is of interest to all?
About the book, is it we can download it? Or
Yeah. So regarding the book, this is the Eloquent JavaScript 3rd edition. The 3rd edition isn't available in paperback yet. It will be in October, but it's totally free online, so please use it online. And it's even better if you use it online, because you can alter all the examples. If you want a paperback, I think I've mentioned before that developing web, the professional web development or something like that by Sakas is a good book, but you could there are probably newer books, and I think there is one called You Don't Know JavaScript or something like that. That is online as well, that you could utilize if you like. I mean, JavaScript, you will probably find the best resources online anyways, because that is how the community is. It's quite open, and you will probably find the best resources on YouTube and on open books on GitHub. Next week, we will get into the fun stuff, because the fun stuff and the things we've been waiting for is to start coding in the browser and start doing things with JavaScript. I mean, I mean, I use the knowledge, the things that we've done today. I use them all the time, because I mean, I have it Node installed on my computer. If I need to do some calculations, or I need to do some basic like filtering out students in a comma separated file or whatever, it's so neat to just do it in JavaScript. You don't need to create a big project. You just create a file and you go. So I use JavaScript a lot, not connected to the web. However, it's when we connect it to internet, then it becomes more interesting. So we will start off by that next week. Okay, I'll be here for yet 20 minutes or something like that until the end of the lecture if you have any questions or something you need help with. Okay, bye.